Hello everyone. Today we'll do the fourth question from the Blind 75 series. Uh, in this question, we are given an array nums and we have to return an answer array so that answer of I is equal to the product of all elements of nums except nums I. So look at the first example 1, 2, 3, 4, and the answer array. The first element is 24. So it is the product of all of the elements in nums except this. So just uh, calculate 2 into 3 into 4, 6, 24. Okay, so this is 24. At second place, 1 into 3 into 4, that is 12. And at second index, uh, 1 into 2 into 4, that is 8. And at this index 1 into 2 into 3, that is 6. Okay, so how would we approach this? Yeah. So one of the very obvious approach is that we just multiply all these elements and we'll get a final product, and for the output we can just divide by the current element. Okay, if we multiply all of these, like 4 into 3, 12, 24, and 1. So it's 24. The product is 24. Okay. Now just divide 24 by 1. It's 24. 24 by 2, 12. 24 by 3, 8. 24 by 4, 6. So we can just easily get the answer. But in the question, they have specifically mentioned you must the product of any prefix or suffix is guaranteed, and you must write an algorithm that runs in ON time and without using division operation. So we can't use division operation. So what can be done? Let us see the brute force approach first. So the brute force is very easy. Uh, for example, you are standing here. So just multiply every other element, multiply this, and this, and this. So you will get this. And next iteration, you are standing here, multiply this, and this. Okay, so you will get 12. You can just iterate through one loop, and in another loop you can uh, multiply all other elements, and for skipping the current element just use the continue statement. Okay, uh, if nums I is equal to if nums j is equal to nums I, then just continue. So it will skip that element. This would be a brute force, and it will take O of n square time complexity. So we need to optimize it further. What can we do? Yeah, so one approach can be we use two arrays, left and right. Okay, and yeah, so in this approach we are creating two more arrays, left and right. So this is left cumulative and this is right cumulative. What does it mean? That this is the product while we traverse from the left side, from this side. Okay, so one is n. Okay, 1 into 2, 2, 1 into 2 into 3 is 6, 1 into 2 into 3 into 4 is 24. Okay. Similarly, for the right, we are traveling from this direction. So 4, 4 into 3, 12, 4 into 3 into 2, 24, 4 into 3 into 2 into 1 is 24. Okay. So we have these both of these arrays, left and right. Now suppose you are here. So for this element, you want the answer. Okay. So we know the answer would be the product of this into this. This would be the answer. So what we can do, the product of this is stored where at this location, right? At this location, and the product of this is here, is right. It's here. Okay. So so we can write a condition answer of I is equal to left of I minus 1 into right of I plus 1. Okay. But for the edge cases, what about the edge cases about this and this, there's no left and there's no right here. So for this, we need the product of this. So we can get this from right of I plus 1, and for this element, we can get from left of I minus 1. So this is how we can create the output array in this approach. Now, this approach would be O of n time, and also the space complexity of O of n, because we are using extra arrays. So to optimize this further, what we can do? So in our next approach, what we can further optimize. In the last approach, the time complexity was O of n and the space complexity was also O of n. We can further optimize the space complexity. How? Uh, First of all, we will not use this array. We'll just use one left array, and that would also be our output array, right? So, according to question, output array is not counted as an extra array. So, our if we are able to just use output array, so we can minimize the space complexity to O of 1, right? So, what we can do, create the left array in the output array itself, right? So just create the left array like as before. Now that the left array or the output array is created, so now it travels from the right side. Take a variable product, initialize it with one, initialize it with one. So you remember what we were doing to find an output for a particular location. For example, if we were standing here, so then the output array was left of I minus 1, left of I minus 1 into this right of I plus 1. Okay, now what is the case? Our left is in the output array, which is this one, and our right is stored in product. Okay, so what would be the output here? Like, how can we take out the output at this position? That would be this array, which is left equal to output. So left of I minus 1, or we can say output of I minus 1. Same, same thing, right? Output of I minus 1 means this product of this into product. Our right array is actually stored in product. So what uh, we have to just like product into nums of I when we are traveling from right. Okay, we have to do this. So product into nums of I, that would be the new product, and we'll multiply that with this output of I minus 1. Okay, so what would be the statement? Yeah, so we are traveling from the right side using this loop, and what we will do that our product would be equal to product multiply by nums I. Okay. This is how we calculated the right array. Okay, so this is the right array, and like in every iteration, we have to update the output array, right? So output of I is equal to output of I minus 1, that is equal to left array multiplied by this product. Okay, product is equivalent to the right array and output is equivalent to the left array. So it's the same thing, just we are utilizing less space. Okay, so yeah, this would give us the output array, the correct output array, right? And for the edge case, when we reach the extreme left, what we can do, output of 0 for this case, it will just be equal to the product, right? The complete product would be equal to the complete product. Complete product would be the product till here, the product till this element, right? 4 into 3 into 2. Yeah. So this is how we'll further optimize it to space complexity of O of 1. Earlier it was O of n. Now let's check the code. We are creating an output array which would not be counted in the space complexity calculations. Let's take n. Yeah. So if n is like less than 1, just return the output. Return output. This is the edge case. Right. Now first what we will do, we will create the left array. Actually we'll create the left array in the output array itself. Right? So let's take a variable product equal to 1, and let's traverse our array, given array is less than n. Yeah. So product equal to product multiplied by nums I, and just push this value output dot push back this product. Right? Now this loop would create our left array in the output arrays. Right? Next, what we have to do, we have to traverse from right, and the elements that we get from the right array would be stored in product itself. Right? Let us traverse from the right side. For in I equal to n minus 1, I is greater than 0, I minus minus. So product will store the elements from the right, cumulative product from the right. Okay? And we'll keep on updating the output array. Output I equal to, what would be the output? Left of I minus 1, that is output of I minus 1, output of I minus 1 into product, right? So yeah, and for the leftmost, we can do is output of 0 is equal to just the product, right? Because while reaching from n minus 1 to I equal to 1, the complete product would be the answer of output 0, right? So it is given, oh, we did not initialize product as 1 yet, right? Because when the left array is created, this product has the value of the rightmost element in this. But when we are traversing from right, we also have to initialize this as 1 again. So now let's run this. Yeah, it is accepted. Let's submit. Yes, it is accepted. Okay, so thank you for watching.